Hi, everyone. I'm Zhamak, and I'm the Director of Emerging Technologies at Thoughtworks North America. I'm excited to be here with you today to talk about data mesh. Why data mesh? What were the challenges we've been facing for over half a century almost with big data management, and what it is. Really deep dive into those core tenets of data mesh that hopefully you can take away and apply to your context and to your organization. One of the perks of being a technology consultant at Thoughtworks is that you get to work with many leaders at many companies across the spectrum of industries. And one thing has been evident for me, that data is at the core of every company's strategy. There are great expectations around it. And I want to just share a few mission statements with you to make this point clear. Our mission is to power prosperity around the world as an AI-driven expert platform. This is from a financial SaaS provider company that many of us, in fact, use their products. And what they want to do is to use data and AI to really change their offerings, what they offer, and how they empower their users and small, medium business owners that use their platforms. The second one from a telco in North America, by people for people. We incorporate human oversights into AI. With people at the core, AI can enhance the workforce. So the ambitions are around streamlining their workforce and how optimizing their business and how they serve their customers using data. And finally, my favorite, from a healthcare provider, our mission is to improve every single member's experience at every single touch point with our organizations through data and AI. And they truly have these goals. They want to improve the experiment of every single member that gets care or other services from this healthcare provider, using the data, knowing their customers, and changing how they interface with them. But the inconvenient truth is that despite such audacious and admirable goals, and despite the large amount of investment that's happening around data and AI, the results on really measurable and transformational metrics are low. Right? Do we have a data culture? Have we become data-driven, competing on data? The percentage of the companies that measure themselves having achieved these goals are quite low compared to amount of investment. These numbers are from New Vantage Partners report that I highly recommend for you to just keep an eye on every year. I've been following their work for a few years to see how the investment versus results are trending. And even though we are getting improved, but still we're not there yet. So the reason data mesh really came about as a hypothesis initially was that we started seeing these failure symptoms in the wild. We started seeing companies really trying to build these big data platforms, but once they're successful in building them, they fail to scale them. They fail to scale sourcing data from diverse set of domains and corners of organization that's producing data with large volumes and rapid pace. And we see failure in scaling consumption of that data, how quickly we can run experiments to use that data to improve, their operations, or how we optimize the experience of our customers, or how many of these experiments can we actually run. So then, often the answer to these points of friction around scaling the source or scaling the number of consumers, and number here refers to number of diverse consumers, like diverse set of transformation, diverse set of use cases, is, let's go and build the next big platform. And then we get stuck in bootstrapping the next big platform that we have to build, and ultimately failing to materialize any value from the data that we're collecting. So I feel we're in this phase of, at least I felt a few years back, that we are in crisis. We need to think out of the box. We need to challenge some of these assumptions and really see what we can do to approach managing and collecting big data differently. So I just want to give you a quick run through of what is the current state of big data and what where have we come from? Like, what assumptions have we made? So as a starting point, we are in this great divide of operational data and analytical data for good reason, right? Operational data is responsible for running the business, serving the customers, keeping the current state. And often we use APIs to serve that data. And on the analytical data side, we have these big data platforms, whether it's a warehouse or lake, which tries to aggregate data from all of these sources and put in some form of a time variant subject focused aggregations of data. And in between, we have this kind of ETLs to get data from one end and put it in the other. That I don't have to tell folks who've worked with ETLs that how problematic they are and how fragile this architecture that separated the two planes, the teams that are managing it, with the integration in between. So then let's focus on the blue part, right? The analytical data. For decades, we've been working on different approaches to manage data at scale or aggregate data. And we've had data analytics, initial versions of, data warehousing to support business intelligence and various business reporting from the 60s. And there are various technologies, often proprietary technologies, to allow you to extract the data from these sources and then model them into some multidimensional systems that you can then run queries and build reports and metrics on top. And in 2010, we realized that, well, this kind of cumbersome and elaborate modeling process of getting data from one end and then modeling it perfectly into this kind of star schemas or various form of schemas so that we can run queries doesn't really serve the needs of today's analytical models, such as running and training machine learning models. So then we decided that let's go with this lake model, which is still get the data from those operational systems, but don't transform so much, dump them into some sort of an object store or semi-structured so that downstream data scientists or data analysts model it however they wish to, but they can still see the signals as they came and in their kind of raw format. And, despite millions of investments on various Hadoop installations that I've seen, we still had a lot of challenges. So the current generation approach is let's do the same, but let's do it on the cloud in a multimodal way. So let's get the best of breed from the cloud providers, get the data out of these operational systems, put them into some big storage, and then downstream use data warehousing or other ways of getting access to the data. So it's a combination of the both and done on the cloud. So we have certainly been going through an evolutionary improvement, right? We had the warehouse, lake, multimodal on the cloud, and we certainly have seen a Cambrian explosion of tooling. So this diagram here is from a VC firm in New York, and they publish the landscape of the data analytics tooling every year. This is from 2020. And I really don't expect you to read every icon, but you can just glance at this and feel a bit dizzy that how busy we've been building various solutions to manage the data and build intelligence on top of it. So then why? We're still seeing big failures in the wild. Why we're still challenged? I was in this wonderful presentation yesterday, Women in Data Science, and almost every second in presentation on data science ends with, we don't have access to data at scale. So why we can't bootstrap ourselves out of this situation? So I think the fundamental reasons, when I really look back at 50,000 feet and look down, I think there are few assumptions that we haven't really questioned for half a century. So I want us to question these assumptions. Are they relevant? So the very, very first one is that, and you've heard all of these phrases, let's collect data in one place. Let's hydrate the lake. Let's, centralize the data that's been siloed in organizations. So we've ended up with these monolithic solutions, centralizing data that is ubiquitously, available across the organization, yes, in the silos of the operational systems, and yet we want to centralize them so we can feed, fuel our innovation agenda, those data-driven experiments. And as we all know, monolithic solutions and centralized solutions are perfect to start with. They're wonderful, easy to start with, deal with one vendor, maybe a small set of technology stacks, but they're very difficult to scale as the, expectation of that platform grows. So then what do? The the easiest path to scale a monolithic solution is technically decompose it, as in look at the technical functions that occur within that solution and put a boundary around them and put them in a box as separate pieces of the puzzle. And particularly in a data platform, we end up with various ways of technical decomposition. And one of them is the one that I have on the diagram here. You optimize for ingestion by a particular part of your solution and processing and serving. And if you kind of recall the diagram that I had around the multimodal implementation of the data lake and warehouse on the cloud, these phases map to the technologies that we are sold by a lot of vendors today. And then what happens what happened to the people, right? So when we have this technical decomposition, the natural way to create teams or create these task-oriented teams, right? As opposed to outcome-oriented or end-to-end capability or feature development, or in this particular case, data development. So we have teams that are responsible for one end and there are teams that are responsible for the other, but change doesn't happen locally to a particular phase. Change often happens orthogonally across these phases. So this all leads to slow pace of development, slow pace of access to data, or onboarding new data sets. And what we found ourselves is this kind of set of tooling that requires a specialization. I mean, who's not struggling with finding data engineers? Everybody is, right? Because the tooling today expects that monolithic piece in the middle be built by highly specialized people that really understands how to transform data or how to read or write data into various technologies. But they've been put in a silo. I mean, I have a lot of empathy for people working in this space because they've been given a task to make sense of the data from domains that they have no visibility into, provided to teams that they have no understanding of how they're going to use it. And yet they have to make sense of this data and provide it to them. Why? Because, they know the tooling that they have to work with today. And like any large, big kind of monolithic solution, building this in a connected way across the domains where the data come from to the domains where data being used is quite challenging. So we end up with these disconnected executions of, start with one end and never finish, or build it and then the users come. All forms of kind of disconnected execution of a big bang kind of solution has been also evident, at least from what I have seen. So for over half a century, we've been trying to manage data and, share data at a scale with a centralized architecture, with a siloed group of hyper-specialized teams, and in a disconnected fashion. So despite going from the evolution of warehouse to lake on the cloud, we are still seeing these failure modes in the wild. So then where do we go from here? If I have a hypothesis, if I challenge, the current paradigm, I better have a solution to look into. So the principles underpinning data mesh are directly designed to address the assumptions and the challenges that I shared with you. The first principle is an alternative way to decompose architecture, decompose ownership of the data. So far, we had decomposers around technology, warehouse, lake. Data mesh suggests an alternative way, and that's really a natural evolution of what organization has been doing. For almost a decade, we've been moving towards domain-oriented decomposition of our organizations, building teams around technical teams that mirror how the business has decomposed itself around the domains and capabilities. So data mesh suggests that let's continue that trend. And when it comes to analytical and big data, bring the ownership to the domains, to the people who are most intimate, familiar with that data. And then the second pillar around that, okay, if we did that, how do we avoid this siloing of the data that we're facing today? Aren't we going to have yet another way of siloing the ownership of analytical data? And the second pillar is addressing that, is that with that ownership comes accountability and responsibility of sharing that data as a product. delighting the experience of all those data consumers, and putting an incentive structure that enables that. And the third pillar is addressing the cost of ownership. So if different teams are owning their big data analytics, capturing it, sharing it, curating it, then how do we enable them? So we need a new generation of technology and automation and platforms that really enables that autonomy. And finally, with any distributed system, we need a new world order. We need a new way of governing data that enables an ecosystem play, enables interoperability of the data without introducing risk, security, issues and so on. So let me quickly go through these 4 principles. And if I'm completely honest with you, I think the main principle is the first one. The rest of them are to compensate challenges and address challenges that arise from the first principle. So domain-oriented ownership of the data. What does that look like? So in the past, we've had this big monolithic, whether it was the data team or the BI team or data lake team, that were responsible for getting the data and owning it. And data mesh introduces the concept of domain-aligned data products, which is around really finding in each domain that's running operational systems, what are the analytical data that they can provide and produce and share with the rest of the organization. So it could be domains that are aligned with the systems that are interacting with the customer or back office, or aligned with the source, or systems that are aligned with the consumers. And then maybe there are a few consumer cases that would require the same data. So we can take the ownership of that and create a new data product, or aggregates, right? Those master data that sit in between, like the customers and orders and entities that go across multiple domains. What does that look like? Let's look at a simple example. And I use the world of digital streaming and digital content because, we all listen to some form of digital content. We might relate to this more quickly. So imagine an organization like Spotify or iTunes or so on. They really have different domains, the domains that are managing with onboarding the artists, or managing, producing podcasts, or managing the users, or the playlists, right? The streams of music. So just look at the podcast. So podcast today has operational capabilities, create podcasts, release podcasts. They provide these capabilities either as applications or APIs. What we're asking these domains now is that now you're responsible to provide your analytical data. So podcast listeners demographic is an analytical data set that could be quite valuable for advertising or event management or growth marketing, any of those kind of capabilities. So now the domain is responsible to provide that. Or based on the podcast behavior, the listener's behavior, they can provide the podcast daily top podcast. So these are some examples of analytical data that now these domains will be accountable to provide. So this transformation to domain ownership challenges some of those basic assumptions that I want to call out here. In the past, we've been obsessed with using the analogy of water, right? The source of life itself. Data flows like water through the pipelines into the lake so that we can use it. And beneath that water and analogy, I think lurks a dangerous notion that it must flow from source to somewhere else by someone downstream so it can be useful. Data mesh challenges that. Data should be served and usable at the source by pushing those cleansing and curation and all of those accountability for getting the data in a shape that it can be used as upstream as possible, as close to the source as possible. For decades, we've been trying to create this one canonical model for our organizations, and domain-oriented design, domain-driven design by Eric Evans actually challenges that. And that's from 2003 in his seminal book on the topic, to move towards a multi-model way of designing the organization. And he introduces really interesting concepts like, the bounded context and the context maps to break apart this complex model to multiple models with intentional relationship between those models. And the last one, I think this one might be a little bit more difficult to accept, but for decades we've been running after this moving goalpost that let's define the source of truth for the data. data moves around, data gets reshaped, that gets reformed, it gets reused, and it's very hard to define this one source of truth. What we can do is create reliable and relevant reshapes and copy of the data if it needs be, and I talk about this in further slides, and put the right automated governance in process to keep those relevant reshaped copies of the data in check. We really need to move away from pipeline. Pipeline as an architectural concept, it's quite challenging when you think about scale decomposition. And let's move those pipelines to internal implementations of domains, and let's define interfaces with clear contracts for sharing data across boundaries of domains. And let's move away from this technology-driven decomposition of our architecture to domain-oriented decomposition and distribution of ownership. So then how do we address the silos? How do we address avoiding this disconnected and fragmented a set of maybe beautifully curated and shared data sets, but they don't yet talk to each other. They don't yet, they can't be really used. If I go back to definition of a successful product, coined by Marty Kagan in his book Inspired, every successful product sits at the intersection of being usable, being valuable, and being feasible technically and business-wise to create. So what does that look like if we apply these characteristics to the data? Let's zoom into the usable. Let's assume that the data is valuable. Somebody needs to use it. Somebody has a need for it. And technology is feasible to build. What does usability look like? One of my favorite books, Don Norman, the father of cognitive engineering, on design of everyday things, starts his book with this idea that every product that we design has to be discoverable and understandable. And I think that's one of the basic characteristics for data to be usable. So discoverability as where the data is, how can I get to it, documentation in both a static documentation, but also computational documentation with likes of computational notebooks, allows that understanding, enables that discoverability and understanding. And I really think we need to move away from this mechanics of, I need a data catalog or data registry. Those are mechanical implementations, and really think about the experience, that first day experience of those data scientists that wanted to run an experiment. Remember we talked about that litmus test of running an experiment? What does that journey look like for them? Because those are the users of the data that we need to delight their experience. How do you go about discovering the data and understanding? What are the native tools that they use? And let's build something that satisfies their needs. The second, I think, usability characteristics that's worth calling out is that the data is trustful and trustworthy. Trust is such a difficult word to define. In fact, one of the most wonderful definitions that I love is by the work of Rachel Botsman. She has a few books on this, but Trust Thinkers is a website, blog post that she wrote. Trust is a confident relationship with an unknown. So we talked about building documentation and discoverability so that we can start bridging that gap between, I don't know what the data is, let me know about it, and bridging that gap. What else we need to do to bridge that gap between known and unknown to trust the data? So we need more information, right? We often refer this as metadata. I try to avoid these overloaded terms that lost their meanings and really get to what we're actually talking about. So let's talk about a few characteristics of the data. How often does the data get updated? What's the interval of change? What's the skew between the time that it got produced and the time that it gets consumed? How complete the data is? What's the statistical shape of it? These are just a few characteristics that are sprinkled here. But every data set, to be usable, should have these basic characteristics. So here are 8 characteristics that I think are baseline to get data usability in place into each of our data products. And I leave that with you to go through later on. So then what does it look like? If we have if you have data now that needs to provide all of these characteristics, need to be trustworthy and with integrity, security built in, documentation built in, we need a new unit of architecture, a new architectural quantum. We call this data product. It's a placeholder for now, placeholder name. But data product is really an aggregation of both code that transforms, serve, and share data, as well as the data itself, and the characteristics, the metadata information that we shared about. And this unit should be able to be built, deployed, and maintained as one component. But all of these requirements around the characteristics and serving data as a product doesn't come just out of good intentions. So we define in data mesh implementations, we define new roles. The data product owner, whose responsibility is serving data as a product, is a long-term responsibility. The KPI she or he would measure are the reduced lead time for a data user to find and be able to understand and use and experiment with the data. Growth of usage of the data, how many people are actually using the data, and their satisfaction. So what sort of transformational thinking, I guess, we need to put in place? For decades, we've talked about data as an asset. If data is an asset, what we would do? We would hoard, we would collect more. And that results to gigabytes of data that nobody can really use. So we need to change our mindset from data as an asset, as data as a product. Instead of collecting data, to connecting the data together. Data as a byproduct of running the business that I really don't care about, to data as a product that my domain serves to the rest of the organization. And finally, data as a dump of a compute, as an output of the compute, to data and compute together as one unit of architecture. So we've had a lot of asks from our domains now. We are asking them to not only run the business with the applications and systems they're building, but also provide analytical data. So can we enable them? Well, this is where really platform thinking comes to play. We've got to abstract away the complexities that exist today for domains to be able to host, transform, and share the data. What does that look like? When we think about platforms, we often think about this basic stuff, right? The metalwork, the networking, CI/CD, big data blob storage, and put a system in place in front of those so the users can request these capabilities in an automated fashion with less friction. But data mesh needs more than that. We need to create the new set of capabilities. And honestly, none of these, up to be completely transparent with you, they don't exist today. These are the new things that we have to build. And hopefully the tooling and technology will catch up to provide that to us as offerings. But we've got to think about the experience of data product developers, the experience of data product users, and create new levels of abstraction, new automations for them to be easily declaratively manage the life cycle of their data product. And on top of that, we need new capabilities to be able to run operations at the mesh level. It's great that we can run, build one data product or two data product easily, but what does it look like to connect the data products together? What does it look like to run semantic queries across the mesh? What does it look like to actually see the health of the ecosystem? That requires a new set of capabilities at the mesh level. So again, to challenge the way we've been thinking, really the platforms today, we've got to stop thinking about the next big platform to build. We've got to think about what are the protocols that we need to enable for different technologies to be composed together to satisfy those capabilities that are just listed in the previous slide. Instead of assuming that everyone is a data specialist, we've got to think about how can we make our data generalists or our data enthusiasts or generalist developers to enter this space. You have no idea how many conversations I'm in that the data platform team is complaining that the business unit or technical units don't have the right data engineering skills. Well, we've got to change that because we will never meet those numbers and expectations in terms of number of data engineers. We need to, take up the level of abstractions, move away from enforcing everyone to imperatively say how to build the platform or how to build the data product, to a simpler declarative model of saying what the data product entails, and then the platform take care of a lot of the metal work for provisioning that, and move away from thinking about mechanics of mechanic of a catalog or mechanical registry, and think about the experiences that we would want to enable. And that would really open up a world of opportunities in terms of building solutions. So what is this new world order that we need to, in fact, enable interoperability, right? So now that we decoupled the ownership, we decoupled where the data sits and how the data gets served, we have this wonderful automation as part of our platform. And it may not be one platform. I know in this picture I have like one platform. It's just a notation to show it's a composition of automated capabilities. The new world order requires embracing a new set of value system, embracing decentralization or domain self-sovereignty. The domains are in control of their data, how they model it, how they share it, while enable interoperability between these domains. What are those standards that we need to put in place? So while we design and model our data across the domains differently, we still speak the same language, right? We can join data across the boundary of these domains. We need to embrace the governance, need to embrace the dynamic topology. Data products will come and go and split and converge. The governance need to be able to handle that. That's just part of the nature of the mesh. And finally, take advantage of the platform. Automate. All of those policies that we create, automate into the platform. So placing a system in a straitjacket of constancy, it's only caused fragility. And that's what we've been doing for a long time with our data modeling and canonical models. And that just simply doesn't work for the world we're in. So very briefly, the components of this governance to think about and apply to your organization include thinking about those global concerns, because really it's about balancing, that's finding that equilibrium between what we're going to decentralize and leave the decision making local to the domains, and what decision we're going to globalize, and we want to have as few as those as possible for the sake of interoperability, right? So deciding what those global concerns are, creating a federated team from those domains, data product owners, and ancillary roles like the subject matter experts in security, compliance, and so on. Defining really the principles that defines the boundary of and the scope of your governance. The principles really should define how you make decisions, right? How you make whether a concern is a local concern or a global concern, and defining those global policies, and as part of those definition, defining how the platform, how they're going to be automated. Like if we decide that we're going to use the same syntax and semantic modeling language for all of our domains, regardless of the domain that they're in, then how can we enable the platform with automation to create these schemas automatically, putting the scaffolding in place, putting the verification in place, a ton of tooling we can enable our platform and verification. Do the data products on the mesh follow these policies and convention, automation of verification, and embed those computational policies into every single data product blueprint. We put a lot of emphasis in automation of blueprint of every data product, the SDKs, libraries, and so on that we use, or sidecars essentially that we use in every data product to really embed these capabilities. Governance is going to look very different, despite having the same objective of providing quality data across organizations safely and securely. Implementation of that is going to look different, from a centralized team of data experts to really a federated team of domain experts. Instead of having the responsibility for quality of the data, for security data, they're responsible to define what constitutes quality and security, and then embed that into the platform. And it's the responsibility of the domain product owners to really meet the assurances of their, the agreements and the guarantees that their data product must meet. They're not responsible for defining a canonical model. They're responsible for modeling the polyseams, the entities that go across the boundaries and require standardization. And again, moving from an asset to product requires changing the measure of success, moving away from vanity metrics like volumes, how many tables tables and petabytes of data you have to really how many connections you established on your mesh, because connections are representative of somebody's using your data and getting value out of it. And that has a different formula. So data mesh, in summary, is really both a paradigm shift in architecture, technology, and organizational structure to bring your planes of operational plane and analytical plane together with a feedback loop among your operational systems and analytical systems coexisting as part of the domain, served by an automated platform and governed by a federated and computational model. The journey of 1,000 miles begins with the first step. And you have taken the first step, being curious enough to listen to me and think about data mesh and thinking about application of that. And I wish you all the luck to take this to your organization and apply it at scale. Thank you.